Right, good afternoon. Or for some of us like me from the East Coast, it's almost dinner time, I guess. Hopefully you had a great day. Thanks and welcome to Building Apps with React Native and Salesforce Mobile SDK. Well, this jumps a lot, okay. So I'm KK Ramamurthy, or at least that's 20% of my name, but that's okay. I'm a part of customer success group. I lead the mobile global practice, and what that means for customers like you is I get involved when you have questions, challenges, anything that you need to when it comes to mobile and mobile SDK, Salesforce One. I'm here with Ivan Bogdanow, and I'm sure I am butchering his last name, but he would do so with my name as well, so that's all good. He's from our products team. He is our internal resident expert on React Native. He knows everything about React Native, so which is great to have him here today. I know we are the last one today, and we are the one between the party and your fun time at Trail at DX. We will make sure that this session is as engaging as possible. And agenda-wise, what we want to go through is Salesforce Mobile SDK, what's it about very quickly, what is React Native has got to do anything with that, maybe show you some quick code samples and demos, and more importantly, Ivan will walk you through some complex patterns and all the innovations that we are doing internally in Salesforce. All right? Just to make sure that this is an authentic Salesforce presentation, by now you probably know what this means, but please, please, please make your purchasing decisions based on what's available to you. We may be talking about some roadmap items in here, so please consider that. If you think about Salesforce mobile app portfolio, we provide a lot of mobile apps which does a lot of things out of the box, right? We have Salesforce One, which does most of the sales code functionality. Then it also helps you to build web apps and surface it. When it comes to field service lightning, wave app, so we have about 10 different mobile apps that do a lot of things out of the box and let you customers customize and extend it to an extent. But when it comes to building native apps, in most cases, especially in consumer-focusing apps, right? When you want to build a native app to absolutely control user experience, to absolutely have those integration, and you really want to control the entire soup to nuts of developer experience and the user experience, then you're going to build apps from scratch. So just by show of hands, so that we can understand what your focus area is, how many of you are here like hardcore native app developers, iOS or Android? 1, 2, 3. I see some from our internal team raising hands. You guys don't count, so great. How many of you are web developers? Excellent. So that's great. That's why you are here, right? How can you use your web development skills and still build native apps? Why do we provide mobile SDK? We know you need native apps to control that user experience, and you just cannot go and make changes to the native app of Salesforce, right? Salesforce One, right? But we want to make sure that you don't reinvent the wheel. There are certain things that we can already package and provide to you as a part of an SDK, so that you can use our SDK, reuse all the nice things that comes out of the box in the platform, but then build your apps on top of it. So that you are not starting from point 0, you are starting somewhere like 20, 30% that's already taken care, right? That's all SDK is all about. If you think about it, SDK does 4 things really well. 1, it abstracts the authentication and the security layer, which means in the Force.com platform, if you set up your authentication, be it single sign-on or be it complex authentication with mobile device management, certificate-based authentication, all of that reflects seamlessly in the mobile SDK. Our own products, like Salesforce One, uses the mobile SDK. So the users are going to get the exact same experience when it comes to authentication and security. Okay? So that's 1. Number 2, it does abstracts the REST APIs. So we are an API-first platform. So you don't have to really rewire all your API calls. You can simply use our abstraction layer to easily call the APIs to the force.com platform. The third thing it does really well is the smart store and encrypted database, which is basically what you can do is store your data locally offline, and we take care of the encryption. We take care of the syncing process using Smart Sync. You just have to deal with those APIs to basically store data into the local database and sync it, right? And then the fourth thing it does is push notifications. Makes that whole process easier, because if you are from the iOS world, you have to register your app, you have to get the device token, you have to register it back, and then if you want to call a push notification from Apex in the platform, you have to rewire it. SDK takes care of that on the client side. So it does all these four things really well, and that gives you an excellent starting point if you are developing mobile apps for the force.com platform. So what I want to show is, where does React Native come in here? So when it comes to native app development, and I don't know if some of you might have been in previous session, which Erwin, our product manager, walked the group through, is when it comes to native app, you are maybe an iOS shop where you are building for iOS using either Xcode, using either Objective-C or Swift, or you are an Android shop. And then there is hybrid, which is basically writing it as web apps, HTML5, JavaScript, CSS, but then surfacing that into your native app as a container with web view, right? So that's the third variant. That works great in many cases, because then you can build once and deploy it on both platforms, but HTML5 is never going to have the same performance benefits like native apps. It's a reality, right? Because there is a translation layer in between. If you want to have really good user experience, performance-wise, smooth user interfaces, you have to build it in native. But then the problem is, there are two platforms you need to support. Some developer shops do it, great, fine. I mean, yes, if you have the resources, if you have the skill sets, but a vast majority of enterprise developers don't have that, right? You don't want to be building 3 different variants of your app, right? One for iOS, one for Android, and then one for your desktop web apps. So that's where React comes in really well, and this is for the engineers at Facebook built it, and some of you might have tried it. By the way, how many of you have tried React at all? Great. So React is a JavaScript framework, and React Native is the native layer of that, which means you write still in JavaScript, JSX, and then run, and React Native actually converts that into native code, compiles into native code when you deploy it to those devices. So I'm going to show you an example of how it is done, okay? And after my example, Ivan here will walk us through some more real complex patterns as well. Make sense? So those are all the 4 APIs in the React layer that you can just rightly use. And by the way, if you want to really look at some example apps, the Dreamos app, you probably have seen this many times in this conference. There is a React Native variant of that app as well. Take it for a spin. But I'm going to use a much more simpler app so that you can understand the wiring and the dependencies. All right? OK, coding time. What is a developer conference without some code? OK, so first thing you're going to do is, once you set up your development environment, and there is, the documentation clearly tells you how to set up your dev environment for the mobile SDK. And one of the command line tools that is going to be readily available for you is force iOS create. Okay? And I'm creating an iOS app, and then I'm going to just iteratively create it. So it's going to ask, like, what type of app do you want to do? Do you want to do native, native with Swift, React Native, hybrid local, and hybrid remote, right? Hybrid local and hybrid remote is the web app side. Of course, native and native Swift is, the native is the Objective-C version, and the native Swift is the Swift version of that. But we are here for React Native, so I'm going to say I need a React Native app. And then what's it going to do is, OK, give me your application name. I'm going to say demo3, com.tdx, whatever that is, tdx. And moment I press enter now, what's going to happen is the force iOS create command line library is going to create a templated app. It's going to download all the dependencies, maybe even connect to some satellites. No, actually, it doesn't do that. So it basically connects to various libraries, downloads all the plugins required, all the frameworks required for us to build a native app, and it's going to give you a templated app. It's going to take some time for that to do. So in the interest of time, I'd already created one. So once it does it, you would go in and open up the workspace in iOS, and this is Xcode, right? I'm doing an iOS development. For Android, you would use Android Studio and Java-based development, right? One thing it does is we wire the app delegate in here. There's a bunch of code that's already put in. It brings in Cordova container. It also wires all the authentication. So the 4 things that I said, all those libraries are imported, and you don't have to do anything, right? So the code is already put in. When it comes to React Native, what you want to see here is it sets up the root view controller, right? And I'll talk about the second option in a minute. The first option it puts in here is it calls index.ios bundle from the local host. So the way React Native works is it basically acts as the middleman, right? Whatever code you write in JavaScript, it converts it into native code, and there is a implementation sitting in between your app and the native side, right? So it wires all that. You don't have to worry about it, right? All we are saying is once this is set up, go and call index.ios. And let's see what with template what we put in is there's a bunch of things. It's just, for React developers, this is very simple and straightforward. You are importing React native libraries. You are importing other libraries. For example, in this case, I'm using a list view, a text view, whatever that is, right? And there is a bunch of JSX code. Now, how does that look when I run this in a simulator? So when I launch this app in the simulator, and you are seeing the simulator on the right side, let me bring this in here to the center of the screen. First thing is this is the authentication flow, and you didn't have to do anything, right? So the SDK actually did this for you. And this is exactly the same experience your users will get if they're using, say, Salesforce One or any Salesforce app. And if you set up single sign-on, it's already taken care here, right? So this is the first screen they're going to see. And when the user says login, hopefully I paid my dues. Hold on. OK, there we go. So it starts the OAuth flow, of course. Let me, sorry? Well, yes, it does. And then, this is a real demo. So when demos break, it's real. It's not cooked up. So it's going to take a minute to launch the app. And then as you see, right, it's in the login. So you're going to see my password, but that's OK. It's not up. Well, maybe not. All right. So it starts the OAuth flow. It did the whole OAuth flow, and then it's asking the user to allow. Now what's happening in the background? It's already actually negotiating the OAuth flow. It's supplying the user ID and password. It's getting the refresh token, and depending upon your setting in the platform for the refresh token, it's going to maintain that refresh token, which means your users. If you say your refresh token validity is like say 90 days. Then the user doesn't have to key in user ID and password for like next 90 days unless they log out, right? On all those nice features, you really don't have to code. Everything is taken care for you already, okay? And all of that is stored in an encrypted store. So even if the device is lost, nobody is going to know their access token or user ID or password. So this is just a template app. It just shows and connects to the 4 users that I have in my demo org, and the code is here, right? Straightforward code. This session is not about teaching you React. It's about showing you how you can use React apps, right? Now, this is hardly how you do, right? This is just a template app. In case if you have, usually in React world, what you do is you have this one single page app with various routes established, and then you are going to make all the navigation. You're going to make different components, and then you just want to surface that particular single page app in your component, right? In your app. So here is demo 2. I conveniently borrowed A really good app that one of our developer evangelists, Christoph, built. Credits goes to him. But it's an interesting app, right? It's just an employee directory app, and it shows the power of the SDK. And I use the same force create to create that. And when I go in, and let's see how his index.ios looks like. It looks much simpler here, right? So it's basically wiring the React Native library. We're bringing in the employee directory app, which is actually a separate folder in here, which is our standalone app, React app, and then we are just registering it to the component. And let's go take a quick sneak peek of what's in there. So in here, we are actually loading a navigator component. A navigator components is a typical pattern in mobile apps, right? You want to have multiple views and navigate across, which is great. So all of that already React provides, and simple JavaScript, right? Same, you can still use your web development skills. So how does this app look like? So when I compile it and then load it into my device, and I'm just going to show it to you in my on my device, maybe not. Quick time. Bless you. All right, so here is the demo 2 app in here. And it looks nice, right? It looks snappy. It is an HTML5 app, and then I can navigate because I had a navigation controller, and it loads up. I can email, call, and what you can also wire is we have UI APIs available for you, REST APIs in the platform. So Force.com administrators are very passionate about their drag and drop page layout setup, and you don't want to make any changes to that, right? So which is great, we respect that. Use the UI APIs, and you can actually wire it, and the Dreamos app has some examples for it. Now, one thing you want to remember, obviously, for those folks in React area, right? So when we wire it, provided with Force Create, we wire it in such a way that it's actually run in simulator. But if you want to make it run in a native app, you have to comment out this line, and all you need to do is just uncomment this. And then you have to bundle it, and there is a simple React bundling CLI. React Native has a command line tool where you can run this and say, okay, bundle this particular JS file for native, to be loaded to the device. And once you do that, you can just deploy it into the devices, okay? All right, so that's at a high level how we do the wiring, initial wiring, right? So just to kind of quickly recap, we talked about using the SDK, the command line tools of SDK, which is Force iOS Create. There is also a variant for Force iOS Create, which is Force iOS Create with template, where let's say you want to create an initial app with a copy of a template, like your own template, right? You might have a little bit more. If you see, when I did the Force iOS Create, it just created with 4 lines of user data. But you might want to have your own template, and you could do that. And if you go to the documentation, there is also a create with template for Smart Store and Smart Sync, really well done example. So you can create an app and also see how we do Smart Store and Smart Sync within React, okay? So having said that, I want to pass over to Ivan, where he's going to walk us through some of the complex patterns.
Thank you. Hi. Imagine that after our talk, you come home and start React Native project. And by the way, I'm going to demo it from this sample app I have created this morning. just to prove that you can code very quickly with React Native. And there is a bit.ly link for it, so you can look into source code of this presentation. So suppose you created a, yeah, I'm going to show you again. You created a, you started working with React Native, and in general, developer experience is very good in React Native. It's very easy to start. You use great CLI, great documentation, both on React Native side and Mobile SDK related to React Native. There are many open source components, very simple JavaScript API. In general, it gives you productivity and performance. And you roll very quickly, and your project manager is excited, and he starts to give you more tasks. You need to integrate with 5 more APIs. Your UX designer is so excited. He never seen any developer to deliver features so quick. So he starts being creative and creates very complex UX with a lot of interactions and animations. Your project is growing. You get more developers, and now you target different platforms, Android, iOS, and web at the same time. And you need to survive this situation, because when more people come, more work is ready, so it is completely different phase. So basically, what I'm going to talk today is how to survive, pretty much, right? When you get more work, people say, yes, kind of, you say React Native is fast, just prove it. So when you get a lot of code, and especially more developers coming with very different experience, some people with native experience, some with web background, everyone has his own idea how it should be done. And you still need to roll on and contribute the same code, and your code should be still productive and readable and understandable for everyone. So I think the first thing that you need to really focus on in this situation is bridge communication, that layer where you exchange information between native and web. First thing, you need to keep API as simple as possible. Pass as little, basically all the methods should be very readable, immediately understandable what it is about. Second thing is bridge communication sometimes can be slow. This is pretty much probably the most problematic part of React Native, is that you always have to cross-bridge between native and JavaScript world and serialized, deserialized data. So you want to be very economical about communication. You don't want to pass too much information. You want to pass exactly as much as needed. Apply moderate caching. Basically, cache only stuff that you are sure you're going to reuse later in your JavaScript layer. Batch requests, this helps a lot, because in general, React Native is very fast, rendering is very fast, so sometimes you can get in a situation when within 100 milliseconds, your code may create 20 calls to backend, and this is something that you want to avoid. And in general, actually, coding for React Native feels, for web developers, experience is something like coding server client. So basically, server is your native part, and client is your JavaScript thread. And you can basically reuse the same, if you have a lot of web development experience, reuse the same approaches and philosophy. For example, Mobile SDK uses native code, React Native configuration of Mobile SDK, has database and networking implemented natively, and React Native calls this code through the bridges. React Native could have called REST API directly, but for security reasons, Mobile SDK is wiring all these calls through native. So basically, next question, when you have a group of people working on features, what part of stuff should be implemented natively and what part should be done with JavaScript? When you decide how it should be implemented, you need to first think about minimizing bridge communication. One thing that is very important is JavaScript bundle size. JavaScript thread on mobile device, of course, it reminds a browser, but actually is not as powerful as browser, so you don't want to run too much JavaScript code, and evaluating any extra JavaScript code is expensive. So on the other hand, you don't want to duplicate code. So for example, if you have some functionality that is already written natively, probably you want to reuse it and not to have it implemented in JavaScript. For example, let's look into this very simple but probably very popular example. You need to render inside your React Native UI localized date-time string in a local format. Something sounds very realistic and simple, but actually it is not that straightforward because in a browser environment, you have available different libraries, or you may even get formatting coming from browser. In React Native, you are in a JavaScript thread, and you don't have access to libraries. So basically, there are three ways how you could implement it. The first thing that you start thinking about, just implemented JavaScript. After it, you realize that it is pretty hard to do to format local data correctly. So basically, you will want to have a library for it. And usually, all these libraries are pretty big. So second solution could be, OK, I'll go native and format it on native side, and after over the bridge, consume this result, which works, but you need to understand that all calls through the bridge are async, right? So basically, you always, if you want to render something, you will have to, with some delay, render that simple string. And the third solution could be just implement native view. So basically, you just literally say, OK, I'm going to render this date, and just inside native view. And it works actually in React Native. So basically, you can always fall back into native if you miss some functionality and want to quickly implement it. So basically, the most simple solution is actually from inside your React code, React Native code, call native view and pass date there, and let native view just quickly render it to you. Actually, that custom native views technique is used a lot in React Native, and it gives extra flexibility to React Native. So let's consider one more example of custom native views is map. So basically, here you have a React Native page, and inside it you have a native component that is coded natively, but is controlled layout, sizing, everything is controlled by React Native, and React Native passes coordinates into this component. Let me show you how this component is implemented. So this is map example. As you can see, you have region and hard-coded coordinates. And you call this native map view component. So basically, it's just native component with some JavaScript wrapper around it. and pass initial region to it. On the other hand, you can listen to events inside that native component and call JavaScript functions. So for example, on region change, I'm going to render new coordinates. So let's see how it works. So basically, if I drag, as you can see that I'm re-rendering from React Native these components. So basically, communication between custom native views and React Native can go through properties. This is one way from React Native to native, which is the most straightforward, is the safest way of doing it. But on the other hand, there is another layer of events. So basically, you can exchange in between with events, listen to events, and respond to it. Another very interesting example of how communication between React Native and native work is declarative native animations. And this is something, technique how to survive when your UX designer gets creative and starts inventing new UX interactions. So basically, declarative native animations is something that there is a library called Animated. This is part of React Native. And what it does, it actually declaratively establishes relationships between different parts of your UI. You do it with JavaScript, but after it, all the animation is happening on native side. So basically, when something changes and the other part of UI is going to respond to it, I'm going to show it later. JavaScript is not affected at all. So basically, you don't cross a bridge. This is how you can get absolutely smooth animations. And so basically, this is example, and I'm going to show you the code. Here, probably a lot of people who's worked with scrolling know how hard it is and sometimes tricky to do respond to scroll events. So here I have coded with these declarative native animations change color on scroll. So basically I scroll and it smoothly change properties of React Native components. So basically it could be something more interesting, but I didn't have time because I literally started just this morning. So let me show this animation example. For this, we import animated library, which is part of React Native. We set a variable that is actually will reside in native code. In this case, I call it scroll Y. And in scroll view, I inject a listener to on-scroll event, and it will update this variable. But this code is defined in JavaScript, but everything will be happening on native side. And so basically this, and here I define relationship between input and output. So basically I say on scroll from 0 to 500, change color in background, and the same thing, change color for the items when I render items. And this is how this effect is happening so smoothly. And JavaScript is not affected at all. So basically, it's not being called. JavaScript has declared this relationship and stepped out. Animated now is being supported out of the box, supports image, scroll view, text, and view. But actually, if you want to play with this, it's possible to customize any native component with animated library and apply the same effects. Second thing, if we speak about animations, is layout animations. It is different category of animation. It is much more simple to use, but it has some limitations. Basically, it is only about layout update, but very useful. So basically, on every re-render of your view, you can apply certain transitions that you can customize, and it will re-render with this view. So for example, and I'm going to show later the code. So basically, if I click on an item with some effect, it will pop up a new item. And let me show you how it works. So this is the animation that I have defined. And all this can be stored in reused and stored in separate files. So for example, imagine at some point we can actually invite a designer and say, hey, kind of like, if you want to play with this animation, make it more bouncy or anything, how you feel better. A designer can just modify this code without even affecting the actual code. So basically, this is custom layout animation where you define timing and stuff. And this is where all this magic is happening. On a click, it calls add item. And before, and it's clear that it's going to be a layout animation change. And just before re-render, I basically tell layout animation that do transition with this custom layout animation. So basically, it's pretty easy to use, and actually it's possible even to reuse it in any other. It will be kind of like a style. So let's talk about platform-specific code. So for example, you at the same time have to code iOS and Android, and there are some components that are available only for a particular platform, or they look very different. And React Native has very good mechanism for being very kind of clean and readable, but on the other hand, handle all these corner cases. So for example, like the most simple example, date picker in Android and iOS, they are very different. The same thing in Android, ripple effect is available only with the latest versions of Android. And React Native is able to handle all these differences. For example, here we show iOS date picker, but the same code can work actually for Android, and I will show you how it is built. So this is a slide with date picker, and I call example. This is a code for date picker, but as you can see in my folder, I have two files. One is called example.ios.js and example.android.js. So basically, when you build for Android, it will pick up example Android, and if you build for iOS, it will pick up JS. The same thing with ripple effect. You always can check in platform version of Android, and based on it, inject some effects. So now we figured out all this visual stuff, animations, rendering, native components. We still have to connect to different APIs and get a lot of data from different APIs and store it somewhere and work with this. So for this, very, very helpful using Redux or a system like Redux, state management system. And in general, I'm going to talk about React state. So basically, in simple examples of React and React Native, there is not too much talk about working with data, which totally makes sense because React and React Native is more about visual stuff for rendering UI, and it's focused on it, and it does it very well. As far as data, you have full flexibility what to use. In basic examples, React is using state to store data, And it has its own, I mean, it's very easy to use, but it has its own problems. So basically, state forces re-render, and this is where sometimes your performance may go down because you update state too much. For this, you need to use Redux, and I'm skipping this and just show you very quickly Redux, shiny, awesome framework. So basically, Redux is not even a framework. It's just very little code. It's sort of like a convention. So everyone agreed how they need to work with data. And this is very useful. So basically, you can reuse a lot of components, plug in Redux, and be compatible with other stuff. So I recommend it. Unfortunately, I don't have more time. Yeah, so basically, if you would like to see how this code is built, I recommend you visiting this link. And if you have any questions, please ask after the show. Thank you.
So any questions?